Good afternoon, everyone. Welcome to Basic Electronics class once again. Hopefully you
Good
have a
afternoon,
nice
sir.
good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. All right, let us wait for a few more to join in. We have around 20 odd people now. All right, so the others are also quickly joining in. So let me start off with the like I always do as a recap of what we have done on the last class and on. So if you remember on last day's class, we had just started off with the course on basic electronics, and specifically, I suppose I told you about the curriculum, the course outcome, the objectives that is required for this course, or that is expected out of this course. And in that also, we have found out that what are the rubrics that we are going to follow, tentatively, at least I can say for the time being, and what are the requirements from my side. Okay, so those things we have discussed in general. So today, let us jump on the first module. Uh, so let me just share my screen. I'll be using both my presentation as well as the handwritten notes, like some class notes. So I'll let you know when what is required. So hopefully all of you will be keeping a track of what we are discussing. All right. So this is where we actually start familiarizing with our topic. So hopefully a few more people have joined in. Let me just check. Have joined. All right, 35. So half of the class was almost there. Quickly, the others are also joining. In fact, I think the time is 1:58. So officially, I can't start it, but anyway, we'll start it.
So
All
should
right.
we write a note, maintain a
So,
notebook?
yeah, ideally you should, or at least I'll specifically mention some points. Definitely those things you have to keep a track of. Other things, it's up to you to keep a track. Anyway, I'll be sharing these details with you. But on the go, I'll be pointing out some notes, some anecdotes and all. If possible, if you can keep it, it's for your own good actually. So there's no hard and fast rule that you have to keep a track. If you are able to memorize everything or remember everything, that's brilliant actually. But anyway, taking notes is a good habit because it will stay with you even after the class is over. So I usually follow the old trend, so it's up to you to choose. All right, so these are the first module, the topics that is to be covered in first module, and where it starts from the evolution of electronics. Then we have the impact of electronics in industry and society at large. Then, as I said also on the last day's class as well, we will do the familiarization of resistor, capacitors, inductors, color coding, types and specifications. But primarily, these things have already been done by you. So I'll just preferably would try to give you some questions, and based on that, I'll try to understand whether you are at the same page. And then we have the electromechanical components. We will see that how the relay works or something like that. So we'll see that. Then the relay and contractor as is mentioned. Then we have regulated power supply, because this regulated power supply, function generator, multimeter and CRO, the last four points that you are observing, these are ideally the must instruments, electronic instruments, which are used for any set of labs that you come across in electronics and even in electrical as well. So this is basically to give you an insight, or like at least to have the knowledge of these items. But as I said, even in the labs as well, that hopefully when we come back, when you are coming back to campus, we will definitely have a hands-on session on all these equipments, and then only you will be able to understand the way it works and how it should be working. Right? But here only we will touch upon the basic principle of how it. So let us quickly start with the evolution of electronics as it stands. So we'll go very quickly with those things. So it all started in around that. Ideally, the evolution of electronics happened in three phases. Okay, like although the phases were like maybe 50 to 70 years apart, but ideally it started with the vacuum tube, the one that you are observing in the left hand side, the animation that you are observing in the left hand side. Then we have the transistors, okay, over here, and transistor being one of the cores as well. We will see that in the third module. And finally, we have the integrated circuit or the IC. So ideally, the evolution has taken place with respect to this formation of these three specific devices, I would say. I would call them the devices because ideally they are standalone components, but these components are specialized components, especially the transistors. And in fact, before this transistor, we will have the diodes. Okay, so again, diodes is as a part of the semiconductor. It is coming in the second module, so I really can't discuss it as of now. But ideally, there will be some specific property by which these devices will be made to work in a circuit, along with the existing components like the resistors and the capacitors and all. All right, so they will have some specific special properties, and that actually has revolutionized the whole set of electronic equipments and the industry, if you call it at large. And it all started from vacuum tube, that is around that 1900 range, like in the year 1900 and all, or even 1800 and beyond. I think I have a table for that. Yeah, here only you will find that the vacuum tube, that this invention of diode called valve, this is where 1904 almost, during that period, it actually started to happen. All right. So in that way, if you observe 1904, that was the valve, the one that you can observe in the left hand side. Okay, this one was created. So this was basically the first invention to indicate that if you have a scenario like this, I'll show you a diagram, then I'll come back to this. So if you have a cathode over here, okay, this is where I'll just make a point. So if you have a cathode over here, okay, and you have an anode over here, okay, which is basically a catcher, if you call it in that way. I think all of you know that. So in that way, what will happen eventually, that the electrons will be caught upon over here, okay. So this same principle was used for the invention of diode as well. But although the materials, the N and P, the hole and electronic concentration, the concepts of it was completely different in a way, but this was the advent of it. Okay, so that's the starting point of it. And later what happened, that based on this, I'm sorry, yeah. So based on this, what happened, that when the second mode of our operation came in, the transistors were setting. So it was around that 1906 and 1907. First, the third electrode between the cathode and the anode was considered. That triode, this was there here. Yeah, 1906, DeFrost. So DeForest was the first one who actually invented the triode, because what he did, he inserted a new plate in between the anode and cathode. And what happened, that the vacuum tube, which was previous to it, was very bulky and it was fragile. Okay, and it which consumes more power, large area, low reliability. Okay, and the requirements like frequent maintenance was required. So all those things were not that good. That's why the vacuum tube diodes were not very, I would say, promising in that way. But then triode came in. And after that, you can observe that after 1906, in the table itself, in 1939, Russell Lowell first invented the PN junction diode, where a N and a P, two different set of elements, would be merged together, and that created a revolution itself. And that led to the invention of transistor, which was a triple combination of three layers, NPN. Okay, so there were three layers which were connected to it, and that was done by William Shockley, John Burdin, and Walter Bratton. Okay, so this was the first time where the transistors actually came into existence. And with diode itself, electronic components found a new way of looking at it. And with transistors, the equipments even more revolutionized. Be it the radios, the TVs, the generic refrigerator maybe, or something like that. Anything on that planet, like it was used for this, were revolutionized by these transistors. In fact, after that, when 1958 happened, where the Jack Kilby was first to introduce the integrated circuit, that actually finally put the nail into the coffin. All right, because it was like the final stage where we are actually giving everything, like everything, the triode, the transistors, all the electronic components, all merged together in a nanoscale in an IC. And that was the biggest, one of the biggest innovation that happened in the field of electronics. So you can observe that this is where this is actually Kilby. Okay, this guy is actually the thing. So this was vacuum tube. Okay, this is where the first diode was invented. This is only a replica that is placed. And this is Mr. Kilby in 1958. Like this is a later photo. He got the Nobel later on. I think in 1997, I think he got the Nobel Prize for this innovations and all. So, but he invented the transistor around that 1960s, right? And finally, you can see this Robert Noyce and Gordon Moore. They were the innovators for the microprocessor, the the basic unit, the basic processing unit for which all these computers, all the smart equipments that we come across, they are working, the processing unit. So that was the first integral part of the innovation from Robert Noyce and Gordon Moore. There are many other innovations as well which went on in between, but these are some of the significant, because if I go on talking about the different other innovation that has happened in between, that itself is a individual class that we need to have for the evolution. But this is basically the trend in which it has evolved. Okay, now microprocessor led to different VLSI techniques, VLSI technology, that is a very large scale integration where the innovation was humongous. Okay, and we actually have a division of VLSI in our department as well. I guess all of you know that. So like that, it's a separate stream itself. So you can imagine the depth and the gravity of a stream itself. All right, so that is how big this process is and the significance of it. So I can see this is just to mimic the scenario where we are in, that what is the advantage of an electronics. So you can see that just because of this electronics and all the necessary innovation that has happened, a kind of desktop, the whole room is now inside a laptop itself. So basically everything has a digital format. Now with every day's innovation, we now will have a soft copy or a software version of the same thing that we used to have earlier. That actually had a different implication, because we went from analog circuits, we went from analog electronics to digital circuits or digital electronics for some other reason. So, but analog, be it analog or a digital, they are all electronics itself. All right, so that is basically where the evolutions of electronics has happened over the years, and it's going on. It's going on now. Even we are working on system on chip, where it is scaled in nanoscale. So you can't even imagine how small it is, in which people are going on innovating things, applying new research and all those things, right? So that is where the change is. So ideally, the impact of electronics in industry and society, if we come to the second point, definitely, I don't think we need to introduce anything to you, because broadly it can be classified in any of these categories, like it's entertainment, communication, control, medical science, defense, industries. Everywhere you find the electronics would be there. So for example, in case of entertainment, communication, now I guess all of you are familiarized with a mobile phone, and you have a laptop, and you are connected to a Wi-Fi or a hotspot, and you are actually working with the laptop or a mobile device wirelessly, right? So this wireless connectivity, okay, that also is one of the major boost or major thirst area in our communication or in electronics, which has evolved because of the electronics itself. So you just I wanted to give a relationship in over here. Like if you check that, if I take one part as VLSI, that is where the electronic semiconductor people, like people who are researching on semiconductors and devices are working. Suppose they are working in a specific domain, right? Now they are making the chips that I'm talking about, the IC chips and every components, to be as smaller as possible. If they are not able to do that, or rather if they are, since they are able to do it, we as an end user, we are using a device like a mobile phone, which is very common to all of you for understanding, and that mobile phone has everything inbuilt. Okay, so that is how the innovation from the hardware is affecting the life for a common individual. And in that, you will have the antennas, you will have the amplifiers, you will have the oscillators, all the circuitries, what we would be studying at some point, but all in miniature version. So that is how the different industries will merge together. You can see over here the diagram in the right hand side, which I have mentioned over here. So this actually depicts how this can be connected or interlinked somewhere. So everyone is dependent on the other. All right. Similarly, if you observe in the control and the instrumentation, so these are some of the devices which ideally, you, as I said, you will be looking at it. In fact, the one that you are looking at over here, the one that you are looking uh, over here is basically a CRO. Okay, this is also a kind of function generator. This is a oscilloscope, in fact, signal oscilloscope or mixed signal oscilloscope, in fact, of Agile & Company. So in this all, what you are looking, we are measuring things, we are analyzing. Okay, suppose this graph or this pattern that you are looking at, the peak point that you're observing, this actually amounts for some significant observation. Maybe a threshold has been set. So if it is beyond the threshold, the system is working properly. If not, there will be an error. So those kind of control and instrumentation can also be done using those equipments. Now, what is inside all these equipments? Electronics. So that is what the advantage is, or the impact of electronics on all these components. As I said, CRO, frequency counter, digital multimeter, all these are part of electronic innovation. Okay, so that is how the impact of electronics is coming in control and instrumentation. Goes to medical industry, same way, ECG, EEG, artificial pacemakers, laser-based signal instrument, everything. Okay, MRI scan, ultrasound, I think all of you must be aware of it. So those are all the equipment, sophisticated equipments which are used with the same way, impact of electronics. Same way with the defense industry, very much dependent on the radar. I guess all of you have heard the term radar and how it works. So this is basically the principle how it works, that whenever there will be like signal, this is communication, to be honest, or wireless communication, in fact, or even if you can call it a satellite communication, in fact, in some way. So where you are actually sending the data, or you are sending a signal which will hit the target and it will come back to you. Okay, and that will give us the distance of the target from the transmitter. So that will give us an indication about the nature of where our enemies are. So the same way this radar works. And as you can see, that actually revolutionized the World War II. Okay, so you can imagine the impact and the enormity of this of a science in an application area. All right, so that is how it is. So present day warship missiles have all been controlled by electronics. Nowadays, like even the smart controls are there. Like we will just push a button and everything will work thousands of kilometers apart. So many things are there, right? So in general, as I can say, so these are the different gadgets, ease of booking, e-commerce. Okay, everything has blossomed because of this industry, or for the electronics itself. So there's nothing much that I have to specifically point out over here, because you already are familiar with the innovations of electronics in day-to-day life, and effectively these are being used at some point. Even in your house, you will find lots of electronic equipments and gadgets which are being used. So that's why it is an integral part of our daily life. The important is that. But apart from that, what is happening, that as we are purchasing or as we are procuring more and more electronic thing, one of the concern part is the e-waste. I thought of telling you this as well at some point, because uh, you as an engineer, as an individual, you should also be aware of this, about the e-waste that is happening, which is again a very concerning fact. As you can observe, that this is a graph which shows that around by 2025, the nature of e-waste in megaton, this is, it will be around this nature. Okay, 1.8 megaton. So it's a huge increment that is observing over from 2007 to 2025. This is a prediction by 2025. And if you consider that India's market in early 2012, the investment for electronics industry was around $69.6 billion. Whereas now in 2020, almost I have the record of 2020 till, it was around $400 billion, almost approximately. All right, so the prediction in 2027 is around $90 billion. So you can imagine the amount of usage of investment that it will happen. And investment means why? Why will you invest in something? Because the amount of procurement people are doing, right? So that is what the idea is. So that is one of the biggest concern, that how we are going to manage or map accordingly. One of the easiest solution is, you can observe, like it's a very common thing. You might find it interesting. You will find that the new set of mobile phones that you are using, like any device, any company, if you call them, you will find that in the specification there will be specifically mentioned that it is 4G enabled or 5G enabled, or like that it will be mentioned, right? Some specifications will be given. Why it is given like that? One of the reason is to reduce the e-wastage, because when people, I would call you from the point you will understand this, when actually in the initial stages of mobile innovations came in, the 2G phone, the Nokia handset, I don't think you people will be fully aware of those things, but when it came, so that was a different generation, and people were not very bothered with the changes that it might have. So the second generation phone were not capable enough to continue because it was not supporting the third generation of mobile communication. All right, third generation means where people started to believe in mobile use as a data. Just you imagine in that way. Data means like the browsing, the internet service, YouTube, and all those things. That's data. So when people started to use it, they found out that the earlier generation phones were not equipped to use this for this generation. So what did they do? They will just waste. They will throw away those old phones, and that is actually an e-waste that is happening because you cannot use them. The technology itself has redundant the whole process. So now you imagine that millions of phones which were used globally, which were using those particular technology, is completely waste. It doesn't have any usability as such. So you can observe that here I have specifically mentioned that with rapid changes in technology, changing media form, falling prices and all. Yeah, so planned obsolete, this all leads to e-waste. So people are working on this so that the health hazard is minimized. All right, so this is about the impact and the evolution of electronics that has happened. Now let us quickly go into the details of the familiarizing the register. As I said, already we have done this, or at least I will have an idea that you already know it. So I'll go on asking you a few questions at times, which I would expect you to answer. So anyway, the first thing is that resistance is nothing but it's a free flow of electrons through a conductor. So that's basically where it will, whenever the conductor is moving, it will oppose it to move. So that's basically where the resistance comes in. Simple example, as you know, that if you rub your hand, it will become hot. Okay, so that's the same thing as the resistance also. Friction will create the amount of hot the heat that will be generated. So so that same thing is applied to the resistor as well. You can observe in itself the animation which is over here. So this is a single simple copper wire with a conductor, and the as if the current is flowing through it, or a simple way. But whenever we have a resistor in between the copper wire, so definitely there will be some amount of problems. You can see it's not a problem, but it actually will create some kind of a blockage while it's going through. So it's not an unlimited flow or uncontrolled flow that will happen. So there will be some amount of restriction, I would say, that will happen to the movement. And all metals, as you can observe, all materials exhibit some amount of resistance, be it small or big. And this is example as ohms, as we know, this is measured in ohms. And I guess power rating also has been taught to you. So power rating is basically the amount of power that can be dissipated without raising the temperature too high. Okay, so that is basically a resistor's power rating, as we said. So this is something a specification. So always the resistance will have some kind of a power, like how much power it can withhold. That's kind of, you can say. So that is given by the 1/4 watt, or 1/4 or half of watt, or 1 watt. That's some of the standard power rating. Uh, Coming to the symbols of resistance, I think all of you already are aware of it. So this is basically a fixed or a fixed resistor, whereas this is a variable resistor. By variable, how do I understand? By this arrow that you are observing. So this is basically a variable resistor. So let's see the basic classification of resistor in that way, because we have it in the syllabus for the specifications of resistor. So usually we have the three types. One is a fixed type, one is a variable type, the broader category, and the nonlinear resistor comes under three. Mostly we will discuss the three. One is the thermistor, the other one is the photoresistor, and the varistor. So these are the three non-linear resistors for that matter. And in case of fixed resistor, there are many different set of composition that makes it different. In some of them, you will observe that you can just note down those, like what are the features in which they are different. In some of them, you will find that the resistance value is very high. That's why they are used. Okay, the range may be very high, the lower range and the upper range. It works on a very flexible range. So maybe for that purpose it is used. Some of them will be very easy, like very cost effective. For that purpose, maybe they are used. Some of them you will find that the power rating, the power capability will be significantly higher. So different techniques, some of them will have a different tolerance value. I guess so like that. It differs in different ways. So we'll see that one by one. What are the primarily the advantages and the features for all this resistor? I don't know how many. Just on that note, if I stop for a moment, have you been taught this part earlier? Can anyone please confirm that? Has it been taught to you? Because based on that, I'll put things on the presentation, or I'll show you things. Otherwise, I'll just skip, and that's why I'm asking.
No, sir.
All right.
No,
Okay.
sir.
Great. Tick. Okay, no problem. So the first of the lot that comes in is called as the carbon composition resistor. All right. Why these are important? No, like if you ask me, they're primarily theoretical in nature, because as long as you don't take a resistance in your hand and you test it, you don't get that feel. I know that. But at least what you can have is that for the time being, you can keep a note of all this commonly available and studied resistor, so that whenever you come back over here, you might be interested in finding out how this is in real life. Like while coming to the labs, you can find out this different set of resistor, if at all available, and you can check it on your own. That was done in theory. Let's see how it is working in practice. So that's, I think, would be more helpful for you. But for the time being, let us see the composition of carbon composition resistor. Remember, these are all under the fixed fixed layer resistor element. All right. So that's more. Now, in case of the carbon composition resistor, this is made of exactly the carbon clay composition. You can observe here in the diagram itself. Clearly, it's mentioned that this is inside the main ingredient is carbon clay composition and the plastic base. So the cover is made of plastic, and you can observe that on that plastic definitely there will be the color coding. Hopefully, all of you know the color coding, but still we'll just do the drill a little bit so that we can have a recap of the whole thing. Now, one of the biggest advantages of it is that it is available in a wide range. As I was telling you, some of them has some specific features, and since they have a very wide range of values, you will mostly find that most of the resistance, whatever we are going to use later on in our labs and all, or even you might try back home also if you are interested at times, you will find that this resistance, the carbon composition resistance, are the most abundantly used. Okay, it is very much used commonly. Okay, and you can see that it is easily available in local market and it's very low in cost. So that's why it is the acceptability. Okay, so for conventional testing purpose and all, you can use this resistance quite a lot. You can see that it starts from low value as 1 ohm, it goes to around 22 mega ohm. So this is the range in which it will properly work. The disadvantage is that it's very much temperature sensitive. Okay, and tendency of electric noise due to passage of electrical current from one carbon particle to another. So that is a problem. So it doesn't have a very good power dissipation, you can say, in that way. All right. Another problem, I don't know how many have noticed it, that the tolerance value around 5 to 10, 20%. So can anyone, from your earlier knowledge of basic electrical, can you tell me what do you mean by a tolerance value of a resistor? Can anyone please just tell me what exactly it is? What you have understood of tolerance range? Anyone? Did you come across this term tolerance range for resistor? Because
No,
but you have told, right, the color coding you have been taught.
Sir, it was taught in 12th.
It was not in basic electrical. It was not taught. The subject
No,
that.
sir.
No, sir.
No, sir.
No,
sir.
All right, all right. I have the assumption that you might have gone through this. Okay, no problem. Sorry, my side I didn't understood it correctly. So tolerance range is basically, we'll see that in some time later. Tolerance range is that suppose you have made a 10 ohm resistor. Okay, so you are going to use in a circuit where there is a 10 ohm resistor. Now, ideally, while making of the resistor, the 10 ohm that you have will fluctuate. Okay, it won't be at exact 10 ohm. All right, so it might be around that, maybe like 10 point, like maybe 9 ohm, or maybe it can go to about 11.2 ohm, near about. Okay, so this the deflection of the value that you are getting of the original, what it is supposed to, and what you are getting finally, is the difference, what is called as the tolerance range. So you can imagine, the more skewer, have you heard the term skew? Skew means very short, like it's like the precise, if you say in that way. So if it is low in tolerance, what it will mean, that the value that you are supposed to use for the component will be equivalent to that of what you are actually using. Understood? Suppose you take a 10 ohm resistor and you are using a carbon composition resistor. So as per its own composition, there is a doubt in your mind. Like if you want to, suppose you are using suppose a electronic equipment where the precise value of 10 ohm is absolute necessary. Maybe 10.1, 10.2 is fine, but it can't be 11.2. Understand the scenario. So if that is so precise you require, you need a very low tolerance resistor. So that is basically what the tolerance range is all about. Why we require the tolerance range, or the understanding of a tolerance range. Have I made it clear? What is tolerance range?
Yes, sir.
Understood, everyone? I need a
Yes,
few
sir.
more yes.
Yes, sir.
All right.
Yes, sir.
Great, great.
Yes,
So
sir.
basic, good, good. So tolerance range. So naturally you can imagine that in carbon composition resistor, the tolerance range is pretty high. This is pretty high. You will find that in some of the other resistor, this value will come very low. So that is one other disadvantage of this scheme. So for any precise kind of work, this particular resistor, or not exactly work, I would say network, this particular resistor might not be a very good choice. Right. So that's how it is in carbon composition resistor. The second type of it comes in is called as a wire wound resistor. In that way, I'll just tell you that if in any slide, if you are taking any notes or anything and you want me to stop there, you just inform me once, okay? Because I don't have the idea if you are not telling. So I'll be just skipping to this slide, suppose. But if you are still pending with the previous slide, you just let me know. I'll stop it there. Okay?
Excuse me, sir.
Sure.
So are you gonna upload this PDF on VTop or Teams?
Absolutely, absolutely. I'll be uploading
Okay.
it in BitOp itself. That's why don't
Okay.
write everything from the PPT right now. You will get everything I'll share with you. But if in between, like for example, the tolerance range, just for example, this tolerance range, the explanation that I gave you right now, it was not there in the PPT. All right, so that part you might write it down. That's what I'm telling you. Don't overburden yourself.
Okay.
Enjoy your subject.
Okay. Thank you,
Enjoy
sir.
the study. Yeah. So that is what I'm talking about. That just for your own understanding, keep those small things handy. All right. So next, the next type that comes in, this is also fixed resistor, and that is called as a wire wound resistor. All right. In this, what happens that you can observe that here is a ceramic rod which is placed. All right, and a wire is wound on top of it. Based on that, we'll have a protective coating, and that forms a wire wound resistor. So you can see it's already mentioned over here, the wrapping resistive wire around the non-conducting rod. The rod is usually made of some ceramic because it doesn't dissipate the heat and all. So end caps with leads attached here were then placed end of the rod, making contact to resistive wires. So these are the resistive wires. You can see these resistive wires, and it has a range between 1 ohm to 1 mega ohm. But you can observe that the final range is significantly smaller compared to the carbon one. But the advantage is that it has a tolerance value of only 0.01% to 1%. So you can observe that if I compare it with respect to tolerance value only, this is a huge benefit that we are getting. All right, but the advantage, so the advantage is that it has different sizes, ratings can easily be achieved. So exactly what you want, you will get that particular value of resistor. So that is one of the advantage. So different lengths and diameters can be used because it's a more of a like a solid block of resistor that you are using. It is also having a very high power application ability. High power. It's around 5 to 200 watt dissipation range. So it can now imagine that it can be used for very high power applications where the power dissipation will be very high, so that it doesn't burn out. Simple as that. If you physically imagine that. All right. So these are the advantage. One is the tolerance value is very low, so you will get a very precise rating and usability. And the second one is the power dissipation. But on the other hand, the disadvantage you can observe the cost. That's why I've specifically mentioned in this way, so that you don't need to read all the things in your own way. So the cost is much higher than the carbon resistor. So normally is used where carbon composition resistor cannot meet the purpose because of its own limitation, like the tolerance value and all those things what I have discussed in the previous slide. So based on that, we are going to use the wire wound resistor. But you will soon find that there are other alternatives to wire wound resistor as well. So this is not the end. All right, but this is one of the part second of the lot, second of the type that we are observing. Right. So shall I move to the next slide? Any doubt up till this point? Anyone having doubt?
No, sir.
No,
sir.
No, sir.
Great. Just one or two yes sir, no sir I need require so that I can move on. So the next one is called as a thin film resistor construction. Here also there are two types. One is a metal film resistor and the other one is carbon film resistor. The other one was carbon composition resistor. This is carbon film resistor. So you can observe the made from high grade ceramic rod and a resistive material, a very thin conducting material layer overlaid on insulating rod. Let's see the diagram. I think we have a diagram somewhere. Yeah, I think this is the diagram. In fact, this is on another set of metal film resistor. In fact, so let's see what is the construction of it. So it is means of resistable film. It's a film that is coming as a pure carbon or a metal onto an insulating core. So the insulating core was there even in the wire wound as well, but here there is a pure carbon film that is attached to it, not a wire. And in that way, the major advantage of this is there are many the construction is almost the same. You can see the metallic cap fitted to both ends, and the same thing is as that of resistor. These are the end terms which are coming out, so we can connect a positive and negative supply like that. So you can observe the advantage. The advantage is that it has a 10,000 mega ohm. Can you imagine the amount of resistance it can withstand? Okay, 10,000 mega ohm, and the size is much smaller. So you have a very high range of resistance, as well as the size is one of the biggest advantage. The smaller the size it is, you can observe that you imagine in this way, if you are shouldering a board, if you are designing a system where you have to have small spaces, you actually can use this resistor to accommodate such a case. All right, so that's why they are being very useful. Another thing is that you can see the accuracy level is almost plus minus 1%, which helps in high grade application. So that is one of the biggest advantage of using. As I said, that it goes on like one after the another. It has in advantages each and every one. This doesn't have much of a disadvantage. In fact, it doesn't have much of a disadvantage. In fact, maybe the costing will be little higher compared to the carbon coated resistor. But in this case, the efficiency is much better, in fact. Whereas if you look at the the last one on this lot is the metal oxide resistor. In this also what happens that the same kind of thing happens, that it's a similar manner to carbon film resistor, except that the film is made of tin chloride. This is a specific element which is being used so that it can withstand around that at temperatures as high as 5,000 degrees centigrade. All right, so it's a beautiful innovation in a way, and it's being used in many applications for that matter, where the temperature stability is very important. So available in wide range of resistance with high temperature stability. Okay, so that's a very important feature. You will come to know later on when we go for the other devices. You will find this temperature will play a very crucial role for most of the electronic equipment and the devices. So that's a very crucial and a very important advantage in that. Level of operating noise is much lower, and that's why it can be used for high voltages as well. No problem at all. The difference is, as I said, the disadvantage. One of the disadvantages is very costly than the any other type. Okay, because of the construction itself, the manufacturing itself, it's complicated, so it's very difficult. Like in a way, it's more costlier compared to any of the other things. But again, it depends on the application. If the application specifically require that, we have to use that. Even in capacitance, you will find there are different capacitance, like a tank capacitors or normal conventional capacitors like that. So there will be different application based on which, if that is required, that specific electronic component needs to be simple as that. Okay, so there won't be anything. But most of the time, the lab in our labs and our basic experiment that we usually conduct through, they are mostly the first one of the lot, the carbon coated one. That is mostly used because that's more cheaper. So this is all of the fixed ones, the fixed resistors, what we observe. Any doubt with the fixed resistors? All these values are constant, and the fixed resistance is like it's a fixed value that we are observing and the different types that we are observing. Any doubt till the fixed value resistors?
No, sir.
No, sir. Great. Now we come to the second part of it, which is the variable resistor, which is again called as the potentiometer, in fact, where it is used to find out the output potential, or we can control the output potential by changing a wiper. Okay, what is the meaning? You can see the diagram is a little different. The resistance is here. When it was a variable resistance, I'll just stop this a little bit. Yeah. So you have the when it was a variable resistance, it was like this one, and there was an arrow like this. Okay, but here you can see the arrow is like this. What does this mean? That it can be controlled by this knob. You can see that if I go by a construction itself, there is this wiper. There is a wiper over here. Okay, this is the, like if you do a cross section of a variable resistance or a potentiometer, colloquially what we call it. So if you do it, you can see there's a wiper and this is a knob that is connected to it, right? So why what happens that if you can tune through this, if you can tune this wiper up and down like this, the arrow that you are indicating. Okay, if I go back and now I'll show you, I'll just show you the movement. You can see in the right hand side, if you observe in the right hand side, in this particular diagram, it's basically the knob is moving. So if you can manually rotate this knob, okay, what will happen eventually that this particular device internally, there will be a wiper which will also move upward, right? What is the principle over here is that this resistive track that you're observing, it will have a resistance R. Okay, suppose it has a resistance R, and this resistance, that the distance or the length that it has swiped in for the time being, this suppose has a resistance small r. All right. So what will eventually happen that if I consider V in as the input voltage, okay, so V in by capital R, this will be the resistive track, and the ideally when you are giving a supply, the input supply, this will be the overall current that is going through. But now, as the resistance we are considering, the relative resistance that we are going to consider is this small r. So we will get V out. We want to find out what is the V out divided by small r, right? So what will eventually happen that V out is equal to R, sorry, V in multiplied by small r by capital R. So the meaning is that if I can get hold of this small r, because capital R and small V in is all known to us, we can actually find out the output potential. So basically, why it is useful that whenever you suppose you want to have a voltage regulator, okay, you can observe that clearly in this diagram. If you observe right hand side, the glow of this LED is changing with respect to the movement of this. Can you imagine that? As I can't show you right away, I thought of showing you this small little animation. So whenever this potential is changing, the potential current is actually getting changed, and based on that, the LED, this is a light emitting diode also, which we have not discussed yet, but basically this is a source. It's just an output which is also changing based on the current supply. So the variable resistance is nothing but where the value can be adjusted. There is another, I'll just give you one task over here. I would give you the task of finding out what you called as a rheostat. Okay, this is also a type of variable resistor also, but it's not included in our discussion as of now. I want all of you to just search what is rheostat, not during the class hours right now. Don't go and search for it. After the class hours, just see what exactly is rheostat. Okay, it's a very simple process itself. This one is like a circle. You will find the rheostat would look something like a cylinder like this, and there will be a wiper, manual wiper, which will look like this, and there will be wires wounded of this nature. Again, the same way, you will find that this rotation or the movement of this wiper will decide the length of the wire or the length of the resistance or the amount of resistance which is incorporated. All right, so that is basically where we have the variable resistors used. This is very common, very common. I'll also share you the working principle, but it's not needed actually. It's not needed as much, but I'll still share you the details of the working principle also. You will find that how the potential difference is actually getting affected by this distance. You can imagine why, as I told you, that this is a voltage controller, right? It's a voltage changes you can find out. A very common application of this is also in robotics also. What happens in robotics, those who are interested in robotics, suppose a robot is moving its hand. All of you just imagine a robot. Okay. Now suppose it's rotating its hand. Have you seen that very common thing, right? Now suppose it is rotating by some angle. That's why it is rotating, obviously. So if it is rotating, that rotation, suppose a potentiometer is added. So what will happen? Whenever this is rotating, whenever the hand is rotating, that will trigger a rotation in the wiper. Okay. Now, as the wiper is changing, the small r is changing. This is changing. As small r is changing, your output will change. Now, suppose you have a θ1 angle, which is for V1. That is supposed to be taken for a robot, for the arm that will move. I think it sounds a little weird, but still, the understanding purpose. So suppose θ1 is allotted for a V1 potential. But suppose due to some action, this V1 changes to V1 prime. So the potentiometer or the way the potentiometer works can actually decide or detect as a sensor. It can work as a sensor to detect whether θ1 is achieved or not. The angle is achieved or not. All right. So that is how the different ways this can be used. The variable resistor or the potentiometer in different. All right. So this is about the last one, which is a non-linear resistor, as I was telling you. So in non-linear resistor, these are dependent on primarily the light, the temperatures, the applied voltages. These are the three types which we are discussing. So one is that as I called you the thermistor over here. So it is current through a resistor that changes change with the applied voltage. So whenever the voltage changes the resistance, that is called as varistor. Okay, that is called as varistor. And another thing is the thermistor, we call it, where the temperature changes the thing. Okay, so this is basically where the temperature current through a resistor changes as the temperature changes. So that's a thermistor, as we know. And this is a symbol. You can see the symbol changes a little bit different, like here, and there is a T degree over here. And this is the one of the most famous one that you must come across at some point while doing different projects, and that is called as the photoresistors. All right, where the light will change the resistance of a particular device. And all of these are non-linear resistors because current flow through it doesn't depend on the Ohm's law. Hopefully all of you know the Ohm's law, so I'm not repeating it again. So this is not a linear. Like for example, the Varistor. Okay, the advantage is if the voltage can control the resistance. Okay, so suppose you have a scenario where you have a very high voltage. Okay, and you want to have at that point you want to have a very low resistance, suppose. All right, or the vice versa. Okay, so maybe I'll just start with that itself. So you can observe that at 250 volt, suppose this is what the varistor is. At 250 volt, the value of resistance is very low, and the graph when the voltage is very low, the resistance is very high. So this is basically where what happens. See what is the application? The application is for the voltage spike. Okay, whenever you are supplying a voltage, mostly it's an AC supply, so there will be a spike. And all the devices, all the electronic devices that we have, they are working at a specific voltage. All right, maybe 6 volt, 12 volt, whatever it is. Now, suddenly, if there is a spike, that spike will damage the equipment. So definitely there will be this varistor which will arrest the voltage. Whenever the voltage is very high, suppose there is a very high peak, the resistance will also be very low. Okay, and that way it can reduce, it can protect the circuit from destructive voltage spikes. Similarly, there is another one that I told you, the thermistor, where it actually depends on the temperature for that matter. So thermally sensitive resistors whose prime function is to exhibit change in electrical resistance, very commonly used for refrigerator, AC, whenever the temperature differences are to be taken care of. Why it is advantageous? Because it has a negative temperature coefficient. Negative temperature coefficient. What does that mean? Negative temperature coefficient. It means it decreases in electrical resistance when subjected to an increase in body temperature. So if the temperature increases, the resistance decreases. So it's an opposite way. All right. So that's why it can be used for the temperature control devices. Any temperature control devices will have a thermistor somewhere. It's basically a detector. It's kind of a detector, you can say in that way. All right. So that is another non-linear device. As I was telling you, the last one, where we actually will end our discussion maybe, and that is called as the photoresistor or the photoconductive cell, or the famously called as LDR or light dependent resistor. Okay, and these light dependent resistors are the advantageous one, because in most of the time, suppose you want to find or you want to develop a circuit where it will depend on whether the light is sensitive or not. This is very commonly used. You will find that when you are using a mobile phone, okay, if you are using a mobile phone and if you are switching it off or you are switching it on, okay, so as the light is falling on top of it, you will find there's a mode called automatic brightness. Have you observed that anytime? Automatic brightness in your phone. How it controls? How it controls? The same thing controlled is through an LDR. The more the light, suppose in the morning time, when you need a more light, it will be illuminated, more light, the darkness, the screen resolution will be lesser. When in the night, when the light is less, the brightness will be increasing, right? So the same thing, that is the application of an LDR, the very common application of LDR. So you can see the principle is simple. When light falls on the photoconductive cells, then there is an increase in the free electrons or electron hole pairs. Since we have not discussed electron hole pairs as such, I'm illuminating for the time being, I'm excluding this term. So due to light energy, which reduces the resistance of semiconductor. So this is also having a negative temperature coefficient. All right, so this is about the LDR being used, and the construction wise also you can see these are the two electrodes, okay, and this is a wiring. This zigzag thing that you are observing, this is a wiring, okay. So I don't think it requires more depth apart from this. And the constructional details also is waste of time, so we don't need to do much. But you can observe that basically this wiring, if you observe carefully, this is the base, the ceramic base that you are looking at, and there are two electrodes which are placed over here. Right, there are two black colored electrodes will be here, and this is the wiring. Okay, this is the wiring that comes in. These are the two terminals through which it is connected. So it's the same resistance, but it's a different set in that way. And this gray color part is the photoconductive material on surface that will actually accept the light and it will get indicated. So you can see that how it is working over here in this animation. Okay, so light is falling and that's why it is about to give a supply over here. So only when light is there, the connection is made a short circuit. So that's all about the part. And I think this is being done. As I said, you already know it a bit. So I'll just touch upon this and maybe we'll finish off on next this class as well. We'll continue on the next this class as well. But usually for the resistors, we have the color coding through which we can actually identify what is the value of the resistance. And that can be done with different bands, 4-band resistor, 5-band resistor, even 6-band resistors are there. 6-band resistor, I'm not showing you at this point because it's rarely used in our practice. Mostly the resistors which we are using or which we are going to use are either 4-band, mostly this will be used, and maximally 5-band resistors are there. So I want you to find out what exactly is 6-band resistor. Okay, the color coding for 6-band resistor, please make a note of it. and find it out on your own. So what happens in 4-band register? Simple as that, that the first and the second digit of the value is the resistance value. The third band is nothing but the number of zeros that needs to be appended, and the fourth indicates the tolerance value. So let's see very quickly what exactly it is. So simple as that. So example, hopefully you can also give me some insight on this. For example, this is orange, this is red, right? This right hand side, if you observe, this is red. Okay, this is red. This one is purple, so this is violet. Okay, and this one is brown color, so this is a brown color, and this is golden, so golden. Okay, so this is how it is meant. So since it's a 4-band, why it is 4-band? Because there are 4 bands over here. Since it's a 4-band register, the first one is indicating red. Now, as per the table, red is indicating 2, so the first element is 2. Second one is violet. Violet indicates 7, so the second element is 7. The third element is brown, and the brown, but for the 4-band register, the third element indicates the multiplier. Multiplier. So multiplier, you can see this is the multiplier column. So for brown, the multiplier is 10. Okay, so it is multiplied by 10. So that's why 27 multiplied by 10 is 270 ohms is the unit. And as the gold is placed over here, gold is the tolerance value. So for gold, you can see here gold, the tolerance is plus minus 5%. So the plus minus 5%. Very clear with this? How it is done?
Yes, sir.
Yes.
Clear? This I think already you have done it, so I don't think that will be a much issue. I think this also you have already known by different names or something to understand what are the nomenclature or what are the color which are pleasant. So it's B.B. Roy of Great Britain has a very good wife. So you can see the color I have given. So black, brown, red, orange, green, blue. Then we have violet, gray, and white. It was supposed to be white, but I can't give you in white color. It can't be seen. So this will be white. So if you take all the first letter, it will be the same nomenclature as that of this orientation. Okay, so B.B. Roy of Great Britain has a very good vibe. So these are the combination. So based on that, we can find out from this. Even for the 5-band register, what happens? You can see in the 5-band register, first 3 bands provide the first digit, 3 digit, and then we have the third band for the third band is only used for the when the tolerance value of less than 2%, and the fourth gives the multiplier, and fifth gives the indicator. Same thing. So here 100 means. So here if you check the 1 for again, so 1 is indicating where this is supposed to be brown. The color is not that prominent, so this is brown. These two are black for sure. So this is black and black. Then this one is an orange one. All right, so this is an orange, and the last one I think it is silver. Okay, so you can observe, is it silver or is it? I think it is. I can't see it in fact properly. I think this will be if it since it is 1. If it is 1% tolerance, so definitely it will be something coming around that brown only. It has to be, because if it has to match with this writing, it should be 1%. So basically what happens, this is my blue, this is my first one is brown. So this is my brown.
Excuse me,
Yeah.
sir.
Sorry, yeah.
Sir, the time is up. I have a class in 5.
I'm sorry. I haven't checked it. I'm so sorry, dude. I'm sorry. I'll just stop it right away. I will continue from here. I'm so sorry.
Thank you, sir. Thank you so much.
I'm sorry.
Thank you, sir.
Yeah. Please go ahead. Please go.
Sir, will you?
Thank you, sir.
Thank you,
Thank you,
Thank you,
sir.
sir.
Thank you. Thank you, sir.
So what about attendance, sir?
I
Thank you,
have
sir.
taken attendance. I'll take the attendance in my own way. Insight. I'll take it. No problem.
Can I share the
Thank you.
PPT, sir?
Thank you, sir.
Absolutely. I'll share so that you can study for this weekend. Yeah.
Yes, sir. Please share it.
Absolutely. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hi, sir.